Hello, my name is Rasik Khatka. My college ID is 240629 and my Coventry ID is 15934903. So let us start with our demo presentation of the vertical search engine. Our vertical search engine consists of three main components: crawler, indexer and query processor. Let us begin with the crawler component. So what our code basically does is that it will visit the website of School of Economics, Finance and Accounting, and it will iterate through each of the author's profile. So when it visits the profile of author, it will crawl all the research articles that are published by the author. It also checks the robot.txt file, as you can see from here, to set the crawl delay. The crawler will take some time to crawl through all the articles, so for now we will be using the existing crawl data which is stored in the publication.json file, which can be seen as here. So yeah, this code will crawl through the publication and store the data in the publication file. From the file we can see that the crawler has scraped the data of publication title, author, name, link, publication year, journal and the link of the research article itself. After the crawling process, next step will be the indexing process. So we will perform indexing in order to store the crawl data in a more structured manner in order to provide more accurate results. Before indexing, we also need to perform pre-processing techniques like tokenization, stemming, removal of special characters and stop words. This is done so that the data is indexed properly. And the indexing is also stored in a inverted index.json file, such as this. Here, each word is indexed according to the inverted index algorithm. Finally, there is the query processor, which calculates the relevance between the text and the document in the stored JSON file in the publication file. The pre-processing techniques to the user inputs are also applied for this, and the relevance is calculated by the processor and shows the output. So here we can see that the pre-processing technique is done, and to calculate the relevance between the documents, this is the code. So now let us run the file. Here we have created the web-based user interface as shown in the report. So this is our user interface of the vertical search engine. Here we have the source part and the classification part. Both parts are in the same user interface. So for now we will search economics first. So here you can see that the articles that are related to economics are shown here in the such manners. Here we can also click the publication link and author link, and it will show the publication's research article name and the link of the author itself. Similar to this, we can also search for other finance finance. So you can see that there are multiple finance related articles, and accounting. So this is accounting related. We could also search this based on the research article name, research article title itself. And this is so it in the first. So this is our vertical search engine part, and it shows correct results. Now for the second part, which is the subject classification. So for this we have collected the data from the New York Times and manually stored it in the CSV file. There are, here is the file. There are three categories: politics, business, and health. There are around 120 articles in each category, and a total of 360 articles in the CSV file. Here we can see the title, snippet, URL, and its category, on what category it belongs. Here you can see that it is for politics, and for business we have around 120 articles, and for health we have 120 articles. So this will be used to classify the documents. So where we have the document is, then this code will be used to classify the documents. As you can see, the New York article data. This will take the data and split it into these categories. We will also pre-process this text, such as remove white space, convert it into small word, tokenization, and stop words. And we will use all the STEM data and pre-processed data and use it to train the data into using the multinomial naive Bayes algorithm. So this will create two new save file, classifier and vectorized file. This will be used to classify our documents that are provided by the user. So let us test this output as well in our UI. So this is the classification part. So let us take the classification part. So now as we have taken in order to test the robustness of our system, we will now take the news article from other news sources like BBC or CNBC. So for now, let us take one from BBC. Let us take, this is the business article from BBC. So let us copy this and paste this and classify. So yeah, so our system has predicted that the sentence is of a business category. So similarly, let us take from another news article from politics, and we will click on the first article that is there, and let us take this and see if our system predicts it correctly. Let us click this first. So yeah, our system has correctly predicted the sentence that we have provided is of politics category. So yeah, this shows that our system is working very properly and it is showing very accurate results. So thank you.